right, since we have an hour together today, I'm gonna jump in. Welcome everyone to our webinar on combination heat pump washer dryers in multifamily buildings. We're recording today's session and we'll send out a link to our slides and presentations following the webinar. Comments or questions for other attendees can be put in the chat. If you take your mouse and you hover towards the lower part of your monitor, you should see a little chat box that you can click on for talking with other attendees. If you have any questions for our panelists, please put those questions in the Q&A section. You'll notice that's a separate button there. That will help us find your questions easily. We'll have time for questions before we end our session today. So please feel free to put your questions into the Q&A anytime. If it's a clarifying question, we'll try to answer briefly at the end of each of our panelists' presentations. And then broader questions or questions that might take more time, we'll hold till the end. This webinar was developed in partnership with the LEARN program. The LEARN program is a San Diego-based workforce education and training program that is partnered with New Buildings Institute and Advanced Water Heating Initiative, AWHI, to offer free energy efficiency and electrification webinars. Please visit the LEARN website for more information at sandiegolearn.com. In today's webinar, we're going to discuss combination clothes washers and heat pump dryers, what needs to be known about this relatively new appliance in the American market, how this technology is impacting multifamily building design. A quick overview of our program today. Speaking briefly, these appliances offer energy savings and other benefits. They save space, installation costs, and time. They improve accessibility and how long clothes last. We'll dig in on this more with our panelists. With us today, we have subject matter experts on washer dryers, building science, and building development. Quick introduction to today's panelists. Chris Neighbor is Senior Director of Product Management for the GE Profile Ultra-Fast Combo with ventless heat pump technology. Steve Kemp is a Principal, Senior Energy and Sustainability Specialist at RDH Building Science Incorporated. He specializes in the design of low-energy buildings, including passive house, net zero energy, and zero carbon building projects. Anders Myers, Vice President, Ethos Development, began his career building custom homes with a focus on energy-efficient design, and in real estate development, he is focused on food and beverage retail and mixed-use projects. And I'm Susan Harris with New Buildings Institute, also known as NBI. NBI has been working to improve energy efficiency, reduce carbon emissions, and increase resilience in the built environment for over 25 years. We collaborate with a variety of partners on leading-edge strategies, innovative technologies, and best practices. In the slide here, you can see that I've included a picture from a recent trip that I took. I was in Japan and stayed at a hotel. And when I went to go do laundry, this is what I found, a combi washer dryer. And when I asked the hotel manager about how things were going with this equipment, they just smiled and said, "Welcome to Japan." This is very common for us here. Next, what I'd like to do is to share a video with you about a combination washer dryer, and that's the heat pump dryer. And then Chris will tell us more about these combi washer and heat pump dryers.
This is not just laundry. This is laundry that's one and done. This is the ultra-fast combo laundry machine that does both washing and drying cycles, so you can take a load off. This is cleaning large loads in about 2 hours. No more checking, no more forgetting. Profile is revolutionizing laundry, making any room the laundry room. This is GE Profile. This is not.
All right.
Just laundry. This is
Ah,
laundry.
it just wants to keep playing. It is a very good video. I can't blame it. All right, Chris, can I pass the baton to you? Please tell
Yeah,
us more.
great. Yeah, thanks for having me. Excited to share. Um, yeah, again, Chris Neighbor, product manager for the combo. I've been with GE Appliances for about 23 years and been focused on the laundry for a good portion of that. But I did want to talk about a few things before we really focus in on heat pump. When we talk about washer dryer combos, a lot of people they feel familiar with them, maybe due to traveling internationally, or they may have a combo unit at home. In general, what we find is most people are aware of a condenser washer dryer combo, which is a little bit different than what we're doing on the heat pump side. It may be a smaller unit. Usually they're 24-inch compact units. They have smaller capacity. The key difference is how they do the drying portion. So a condenser dryer is using a heating element similar to an electric dryer, but then instead of pushing that moist air out of the home through a vent, there is a water condenser. So there's a condenser coil that they run the cold tap water through in order to condense the water out, and then that drains out either drains out the drain of the washing machine, or in some cases it'll collect in a reservoir that the consumer has to empty out themselves. A lot of people have experiences with these condenser dryers, and they say that they hate them because they take forever. What's really happening here is that the cycle length is very dependent on those environmental factors, because since they're using the incoming cold tap water to condense the moist air out of the clothes, if that tap water is warmer, then it draws that drying cycle out significantly. So people may, normally under optimal conditions, it may be a 2 to 3 hour wash and dry cycle. But if your cold water is not quite as cold, then it can take significantly longer, 2, 3 times the duration. So when we talk with consumers about washer dryer combos, they usually go to that experience and they say, not interested, they take too long, or not interested, they're too small. So what we did at GE Appliances is we took that feedback. We were looking at technologies that we could employ and decided to launch a full size combo washer dryer that used a heat pump for the drying portion. So it's kind of similar to a large dehumidifier is a good way to think about it. So we run the wash cycle, it transitions automatically into dry, and we're using the heat that's generated from the heat pump to evaporate the water from the load, and then that warm moist air flows across the heat exchanger on the cold side of the heat exchanger that then condenses the water out, and that closed loop just continues on and on and on. So we're able to wash and dry a full size load of laundry in about 2 hours, and that you're going to get consistent performance. Obviously, the larger the loads you put in, it may take a little bit longer. Smaller loads may take shorter, but you're going to get consistent performance. So with these new heat pump combo washer dryers, you're getting a full size unit, so a family's load of clothes can fit into it, and you're getting consistent wash and dry performance throughout the cycles. If you could go to the next slide. So I broke this down into a couple slides of the advantages to the user and the advantages to a developer or a builder. So we'll talk about the user first. So there are many advantages to heat pump combos. The biggest one that we hear from our consumers is the fact that they no longer have to transfer the load over. So they can put their laundry in, hit start, and it's going to wash and completely dry the load. And they no longer have to come back to the unit to transfer the load over. And what we've seen is that's actually changed laundry habits. So, traditionally, people may have their laundry routine where they're doing a lot of laundry on a weekend, or maybe they only run laundry when they're home because they know that they need to move it from the washer to the dryer. With these combos, what we're seeing is that the laundry habits are kind of flattening out through the week. So there's no longer these big spikes on the weekend where people are doing laundry. They're putting a load in before they go to work, and when they come home, they're they're washed and dried and ready to put away. Or they can put them in at night when their family's going to sleep. And when they wake up in the morning, the load is complete. So the convenience is one of the main selling points because it really kind of detaches you from that process that people are so accustomed to doing that with that load transfer to the washer dryer. Another big piece of it is utility bills. So probably everyone on this call is familiar with heat pumps and the great energy saving benefits of them and efficiency. And this is no different. So by using the heat pump for the drying cycle, we're really slicing the energy usage for the dry portion in half when you compare it to a traditional electric dryer. So obviously that's going to have a significant impact on someone's utility bills. And they can have more predictable expenses as well, knowing they're going to be able to be drying at a more efficient level. The other piece that we commonly talk about and we have owners recognizing is, a heat pump is going to dry at a lower temperature because it's more of a dehumidification, and that results in longer lifespan for your clothes. So when we think about green footprint, this is pretty significant because avoiding those high heats on textiles will extend the life of those. So the consumer and frankly, the planet benefit from that as well. The last thing I wanted to mention from the owner standpoint is just the fact that what we're doing is we're developing a new way of doing laundry. This is probably the highest tech way of doing laundry. It provides the most convenience. The other benefit that a user gets from that is the fact that all these combo washer dryers that we're producing are connected, or they're connectable through our app. That allows us to consistently improve the performance of the unit. We're taking all the feedback we're getting from the owners that decide to connect, and we can deploy new software updates to improve efficiency, create new alerts that may be beneficial to the user. It allows them to interact with the machine when they're away, change settings and things like that. So really, when you think about traditional laundry, this is a leap forward for the user's experience of no longer having to do the load transfer, and also knowing that when they use this combo washer dryer for the first time, there's a great chance that as they continue using it, it's going to be getting better and better as we deploy new software updates. Next slide. Now, from a developer standpoint, there are some significant advantages as well. So one of the biggest ones, frankly, is just the simplification in construction, because there's no dryer vent that's required. And because we're using a heat pump, we're able to operate this unit just on 120 volt, 15 amp circuit. So, no more 240, 30 amp circuits for the dryer, no more dryer vent runs. And, there's obviously the benefit at installation, the cost of putting those in. There's also the ongoing maintenance. We hear from a lot of property managers, the ongoing maintenance that's required in some cases on a yearly basis for cleaning out dryer ducts in their units. Anecdotally, they've shared that it could be anywhere from $100 to $150 per unit. And obviously that stacks up as you look at the number of units that may be in a building. The other big benefit I'm sure that my colleagues will talk about are just the improvements from a building envelope standpoint. No more dryer vent, no more makeup air required for the dryer as well. And then from a design flexibility standpoint, we're taking two products, putting them into a space of one. So we're freeing up more usable space. And we've seen this with many of our owners being excited about kind of reclaiming that space and using it for some other, whether it's storage or folding tables. But there's definitely, the benefit of shrinking that footprint down. We've already talked about the energy efficiency. But one of the things that we see, the trend that we see, is just the growing market of environmentally conscious renters and buyers. And this technology, when you combine the convenience, the cost saving, and the environmental impact, it's kind of a home run. Next slide. So I went ahead and listed some of the common questions that I get. When we talk to prospective buyers or, interested people, the first question we always get is it going to take longer to do my laundry? And a portion of that is due to experience with those condenser dryers. But there's also, when they hear it's a 2-hour cycle, um, they think, well, my washer dryer doesn't take 2 hours now. I can start a wash and it'll run for 30 minutes, and then I can take that out and move it to the dryer and start another wash. So there's this idea that this is going to slow down their laundry process. I mentioned it earlier. Really, what it enables you to do is reuse that time. You can run laundry when you traditionally wouldn't want to or wouldn't feel comfortable doing it. And it's surprisingly freeing when you start using one of these combos. The other thing I wanted to mention is we have a lot of data from some of our owners, and one thing that we found when we were originally looking at this project, we found that on average, a consumer will keep their laundry in their washing machine 2 hours after it's completed before they move it to the dryer. Of course, that's an average across thousands and thousands of users. But when you think of that, it's that the fact that they have to do that load transfer is what's kind of drawing that time out. So we're able to do a full wash and dry in 2 hours without that need of a transfer. We also hear, hey, is this going to be suitable for my family? And it's usually around the laundry throughput. And I think I've already touched on these. But we have some owners that are running on average 3 cycles a day. And again, what they love about it is that the flexibility to run it when it's convenient for their family to do it. So that behavior shift, when we see a behavior shift like that, it usually tells us that we're onto something, because we're enabling people to use their time the way that they want to. The last question I usually get is around reliability and maintenance, because frankly, with washers and dryers, if you're accustomed to having one in your home and that goes down for if it breaks down or has an issue, going to the laundromat, and it may not be the most favorable thing for you. So we commonly get people asking about reliability. We're using, we're using heat pumps that we've been using refrigerators for years and years and years. So there's not really any new technology. We're just taking existing technologies and putting them together. And we found that, from a reliability standpoint, they're very robust. The one thing that I will mention though is this is, it may look a little bit different than what you may be used to, but this is the dryer filter. And there is an adjustment that our owners need to make because they're used to kind of a standard dryer filter. And probably the most consistent kind of consumer education piece that we work on is explaining to people how to use a 2-stage dryer filter. Because obviously when we're using this closed system, the airflow inside of it's critical. So this filter has a traditional screen that you would just wipe off and discard the lint. But then every 50 to 100 cycles, we have a secondary foam filter that the users need to clean. And you simply run it underwater and clean off any lint that may be on there and put it back in the unit and run it. That's really the only major difference in kind of maintaining these machines, is making sure that you keep the filter clean. And when you do that, it just continues to perform.
Thank you for that thorough explanation, Chris. Very helpful, very interesting. I see that we've got just a couple of questions here. And one recent one, is the lint filter only for the drying cycle, or is that something that also helps with maybe any fibers like during the washing cycle?
That's a great question. So in general, it's used just for the drying cycle, the lint piece of it. One of the cool things that we launched after this product was originally in the market is what we call a pet hair cycle. So it's a feature that we pushed out as a software update to our owners. And what you can do is if you have pets or things that shed in the house, um, when you enable this mode, what it will do, it will actually run the kind of the dryer blower before the wash starts, and then it deposits all of the pet hair in the filter before the wash cycle runs, because we found that it's significantly easier to remove the pet hair from clothes before they get wet. So another example of like us deploying features and making the product better with time. And one of the benefits you get by having, the wash plus the dry and the filter system in that unit. So it's kind of a neat improvement we've made.
Yeah, that's
Good
great.
question.
Yeah, I have a pet, so I could definitely see value in that. And then also a quick question, someone asked, is there a light or some kind of notification that goes out when it's time to clean the filter?
So we recommend that people clean the filter every cycle, like just kind of the main filter. And then we do send a reminder. The unit has an LCD screen. So we'll send a reminder to the screen when it's time to clean the secondary filter. You'll also get an app notification if you enable that. And then probably 3 months ago, our team deployed a new alert that they found a way to detect when the filter is clogged. So if the secondary foam filter gets clogged to the point where you might start impacting your performance, we're able to detect that, and then we'll send you a proactive notification to your phone and also to the unit just to say, hey, we're detecting a clogged lint filter. Go ahead and clean it before your performance is impacted.
That's great. Well, thank you again. I see we have actually lots of questions popping up in the chat. We've got a few in the Q&A section. Chris, if you're able to
Yeah.
answer some of those over there, that would be great. Also, I'll return to those questions near the end. And just a reminder, if you put questions for our panelists into the Q&A, it'll make it easier for us to make sure that we ask your question to our panelists. But otherwise, feel free to have conversation there on the chat. And I'd like to have Steve join us now. And Steve, if you could please turn on your video and
Yeah,
audio. Could you please talk
preventing
to
me from
us?
turning on my video.
If you could talk to us
There we
now
go.
about, there you are, I see you. If you could talk to us about what this means for buildings,
Yeah,
we'd love to hear about that.
yeah, sure. My name's Steve Kemp. It was introduced right, and I've probably been spending almost since 2001 thinking about airflow in multi-unit residential buildings, a little bit on single-family homes as well. From a building science point of view, and these graphics kind of give you an idea of the sense of the complexity of that. Air is moving around the building, and we don't always want that. We want to be able to control that, especially since you don't want your neighbor's air quality problems becoming your air quality problems. So if you can move on to the next slide. And most of my talk is mostly around the fact that these heat pump dryers are non-venting dryers. They don't need that exhaust. So my talk is mostly going to be around the non-venting aspect and how that enables things to work better. And in single family homes, if you go up a traditional venting dryer, of course, it has to heat all that air and then it literally tosses it outside. And that means that air has to come from someplace else. It could be being sucked down your chimney flue. It could be back venting your domestic hot water system, which means sometimes flue gases are being sucked into your house. It could cause all kinds of challenges. And at the very least, it's sucking in unconditioned air from outside. So not only are you paying to heat your clothes, but you're paying to heat your house again for that air that's coming in or air condition it. And then you put this in the context of a multifamily building. Sometimes that air is coming from outside, but sometimes it's coming from your neighbors. And again, that means that their air quality becomes your problem. So you can move on to the next slide. Um, what's been happening over the last several years in codes is that buildings are becoming more airtight. And I just want to convince you that that is an unmitigated good thing. The circles in blue, those are the things we want our envelope to do. We want it to control water so we stay dry. We want it to control air for energy and condensation issues. We want to control heat so that we're not spending too much money, and so on. And then the green bars on the right, those are the barriers we include in our envelope to control those things. And if you, Susan, if you move, we'll click ahead one more time. Um, Air is one of the more critical ones because it kind of does all of it. It helps out with all these control functions that we want to deal with. It sound deadens. If you have an airtight, air sound travels through those little critical air paths and holes in the wall. And so it can control sound and control fire smoke and so on. And so we want these more airtight buildings. And it's starting to show up in mandatory air leakage testing. It's starting to show up in different codes. Air barriers, of course, are part of all codes. And as we move into multifamily buildings, I want to convince you that the codes are starting to move toward now airtight dwelling unit suites for some of the same reasons. So we can move on to the next slide. Next slide. Oops, okay, one more. And so one of the challenges as we have made our envelopes more airtight was we haven't been as good as making the interior partitions to our multifamily buildings airtight. And not only that, they're residential buildings, so we give people windows. And I think it's good to have a window, except some people open their windows inappropriately. And all tall buildings, in the wintertime, they're really just hot air balloons. All that air is trying to move up because it's cold outside. And, if I have all these air leaky paths through the building, the most significant ones are the elevator shaft, the garbage shaft, the stairwells going up and down the building. A lot of buildings, multifamily buildings, are designed that the makeup air for your kitchen exhaust and your dryer exhaust is meant to come under the suite door. There's actually a little crack under the door to make sure that happens. But it also means that when someone opens these windows inappropriately, when it's windy outside or when it's cold outside, you're actually just whatever bad stuff's happening in your unit or your neighbor's unit, more importantly, the whatever they're smoking, whatever they're burning for dinner, these forces on the building and these air paths allow that air to move around the building. And then we put a vented dryer in and we make sure that that air is coming to you because now your unit's a depressurized unit. So these are some of the issues we're trying to address now with new building codes. Can we move on to the next slide? And the solution is actually very old. Actually, the reason I'm showing the Empire State Building is, the design problem the designers had back in the 1920s is every window in this building is operable. We can open it up. New York is a cold climate in the winter. How do we prevent all that air rushing up the building? And the solution they came up with is if you've ever been in the building, every elevator lobby has airtight vestibules around the elevator shaft. That is, there's a door that swings and auto closers, and it's all weather stripped. And so the basic idea is we can extend that all the way, that compartmentalization philosophy, to the dwelling unit itself. That is, we make sure that the suite walls between neighbors are airtight. Not only the envelope is airtight to the outside, of course, and that the suite door and the partition to the common corridor is airtight. So if you move on to the next slide. And this is actually starting to show up in our codes. So ASHRAE 62 is the ventilation code used across North America. And on the left side, it basically now says thou shalt have individual ventilation system per dwelling unit in multifamily buildings. And on the right, it's telling us to make sure that we're substantially airtight, that even the door between the dwelling unit and the common hallway is to be gasketed and made substantially airtight. So next slide, that starts meaning, okay, so we're not controlling where all those we're trying to control all those airflows. And of course, that again puts more challenge on the vented dryers. They want that makeup air. I did some testing almost 10 years ago. So this was the old condensing dryers that Chris was talking about. But I did about 8 loads of laundry that night, wash and dry. There were separate units at the time. And one of the questions we wanted to ask is, is there any air quality issues from using these non-vented dryers if we're not exhausting that air? The graph on the right is just showing the particulates in the air. They were a little elevated at the beginning of the test. The suite we were using was carpeted, and every time we walked on the carpet, it shot up these numbers. But you can see they stay pretty steady. You can even see when when you open the door, all that, there's still lint in the air from the tumble and the drying process, and that escapes into the space, but that quickly falls. And basically, we weren't seeing any real difference between this test and the vented dryer test. So we can pretty feel comfortable saying it's not an air quality issue. And we did measure the energy use, and as Chris mentioned, it's half. When you go to a heat pump dryer compared to standard electric dryers. And the savings are actually even more than that because you don't have to condition that extra outdoor air that needs to be made up with a vented dryer. Next slide. And then the last, and I think Anders will talk more about this. This actually, where I'm talking to you from right now is the top right corner of that unit, that floor plan. And I actually, when I moved in, or I bought this condo pre-sale, and I knew I was going to weather strip the door and compartmentalize my unit better. And I said, I'm going to get rid of that venting dryer. The developer let me do it, and they gave me a credit for the removing the drop ceiling of the top left up there where the washer dryer space is, and there's no vent, there's no extra lint trap up there that I don't need to worry about cleaning that out anymore. It's also a fire hazard anyway, and I got rid of the another bulkhead in the bedroom, and they gave me actually $1 credit for it. So I think I only spent an extra $100 for the more expensive dryer after I got the credits. Which is all to say, there's more knock-on effects of moving to non-venting systems. And I think this is my last slide, or is that it?
That is your last
That
slide.
is it. So yeah, so from my point of view as the building scientist, there's a lot of good reason to move to non-venting dryer systems.
Thank you for that, Steve. Just a quick question. When you talk about comparing the energy usage for these combi washer heat pump dryers, are you comparing them to a more traditional separate standing washer and dryer?
So we didn't do the combo. When I was measuring it, we didn't have the combo, so we were just comparing the dry cycle. So
Okay.
on either case, it would be the dry cycle.
Mhm.
Now, actually, like I said, that test was 8, 10, 12 years ago. We were actually even measuring top loading washers versus front loading washers, and we demonstrated there was energy savings from the front loading washers on the dry cycle because those front loading washers spin up so fast they wring the clothes out, and there's less drying to do when you get to the dry cycle. Now, I think there's new top loading ones that do the same thing. But yeah, there's a whole, I can spend another 2 hours on that evening of washing 8 loads of clothes.
Oh, that's great. I'm reminded of, like how maybe America's Test Kitchen like tries a dish like multiple ways. I imagine you doing your laundry multiple ways and tracking the differences. That's great. Very helpful. Thank you. I do see questions are continuing to come in, but for right now, I think what I'm going to do is I'm going to move on to our next speaker to make sure we have enough time to hear from him. Anders, could you please join us and talk to us about your viewpoint in these considerations as a building developer?
Yeah, absolutely. So yeah, I'm Anders Meyer. Work for Ethos Development, and we have primarily done market rate kind of infill development in the Portland, Oregon, and Puget Sound metro regions in the Northwest. That business model is changing. We're moving more into affordable and value add multifamily projects. And the sizes of projects that we're doing have ranged anywhere between 35 and 220 units, so quite a variety. And kind of across those different building types and sizes, there are lots of different considerations that we're bringing into these, and each one of those circumstances kind of creates a different set of trade-offs and value propositions for this type of technology. So we've employed it in a couple of different ways, and I'll talk about that in a couple of case studies. But a couple of just kind of broad points. One, as has been said a couple of times, like heat pump technology is pretty broadly adopted in a number of different applications across the industry at this point. So it's something that we're generally familiar with space conditioning, understand the benefits there. And so when we started looking into its application in washing, drying, it was something that felt at least comfortable to explore and understand, because it fits with it's like two of our kind of primary goals. One is generally sustainability. We look for opportunities wherever possible to improve the outcomes of our buildings. We do tend to hold for longer periods of time, so there are benefits, direct benefits, kind of as an ownership group to that, beyond just our belief that it's a better product to be delivering to the market. And then the other thing we focus on, the kind of middle income, depending on how you want to define that, but typically kind of between 80 and 120% of the area median income. So whether you consider that, pseudo affordable or unsubsidized affordable or workforce housing, but for the eventual tenants and users that we're working with, price and affordability are meaningful considerations. So it's definitely something that we think about kind of through the tenant's eyes, how we can deliver a product that's going to work well for them. Let's go ahead to the next slide. So this is the Moraine Apartments. It's in Tacoma, Washington. This is a 160 unit project, and on this particular deal, we really did push both of those, the affordability and the sustainability. We had an investment partner who was very keen to do that, and a highlight kind of outcome of that is that the building was awarded by CoStar as in their annual impact awards, the best multifamily project in the Puget Sound, and again, like really with a nod to the sustainable and affordable outcomes that were a result of that. So some of the things that this is the first project where we included, in this instance, it's actually separate heat pump, dryer, and washer units. So it's not the all-in-one, but utilizing the same technology. And this is kind of where we got our start with this. And some of the primary considerations that went into this were basically those upfront costs. When we were looking at these separate washer and dryer units as compared to kind of what's for multifamily, maybe a typical application of a vented laundry center. It is a little bit more expensive on the equipment side, but as has been discussed, it becomes more efficient at kind of the building utilities level. So a couple of those considerations, really in this project, we had very tight clearances. And so getting all of the duct runs, electrical, plumbing that we needed to in kind of the limited amount of space that we had available was quite a challenge. And so removing the duct runs for the laundries not only save the actual cost of the materials, the install, the time, but it also made the coordination of those other utilities easier because it was reducing the amount of kind of potential conflict that we had in moving through the floor assemblies of each unit. I think one of the other things that I don't have as clear information on, but hearing Chris's comments really made me think another major expense for a lot of these projects tends to be just the electrical service to the building. And the opportunity to use an all-in-one unit that's powered off of 120 when we're looking at kind of an increasing demand in the market for laundry in every single unit, just to be competitive in the market, um, could make a significant difference in just the electric service required for the building, and potentially keeping you at a smaller transformer size or reducing the impacts there. So I think that's something that we'll be paying more attention to in future projects. Um, and then the ongoing maintenance is also something that was discussed, something that we've kind of gone over with our property management teams, and just one more variable that you can kind of remove as a potential liability or cost for kind of that ongoing operational side of things. I think the other main consideration that we had for projects like this is the tenant experience. So to test that out, I installed this in my own home and have been using it and kind of have that experience. Um, and I think we see it as something that we can use from a leasing perspective to uh, differentiate ourselves from other projects, and really be able to talk to our potential tenants about the lower energy utility costs that they'll have moving to our building. And obviously, the washer dryer is a significant part of that. It tends to be one of the largest sources of energy use in a home, but we pair it with other energy efficient appliances. So it's really kind of a whole package that we're presenting to our tenants. Um, I think that the two challenges that we saw in implementing this at this property, one is just that little bit of kind of habit adjustment that's required. So we're looking for an opportunity to talk to tenants about basically the cleaning that extra lint filter. The version of dryers that we have is a little different than what Chris showed. So there are two different locations for the lint filters, and I think that can be overlooked. And it does seem like cleaning that secondary filter makes a meaningful difference in the units that we have on their dry time performance. So that's just something that we need to kind of inform tenants about, and let them know that it's just one quick little step to clean that out, and they should be seeing that high performance from the drying. The other thing that can be a little interesting is just the experience of pulling clothes out. Has a different feel than typical dryers, and so sometimes there are questions about that, like my clothes aren't dry, which doesn't feel quite the same at that first touch when you reach in there, because it's not super dry, it's not overly dry, and it's not overly hot. But when you take it out, let it come to room temperature, you find out that yes, actually the clothes are totally dry. So again, just a little bit of a learning curve there. And then the one other thing that we've found is that because there is not a vent, and like Steve was saying, it's a lot more efficient on the whole building level. But it does mean that the heat that's produced by the dryer is something that does need to be managed within the unit. And so I think the one consideration that we'll be making in the future is that a lot of our units are, because they're urban, because we're trying to create a cost price point that's accessible to people, we're keeping the square footage of the unit fairly tight. And so the heat that's produced during the summertime can require management. And some of our units have air conditioning and others do not. And so in a unit where you have air conditioning, it's not really an issue to consider, but in the smaller footprint units that are also that don't have air conditioning, it can be something that's a little bit more of a challenge to manage. So, I think there are some fairly straightforward things that we can think about that, either different applications kind of across unit types. We are seeing an increasing adoption of air conditioning. I don't need to go into all the reasons for that, but I'm happy to answer questions. And, another thing can just be considering making sure that we're putting it in an enclosed area so that the heat's a little more contained. We can go to the next slide. these second two projects will be a little faster to talk about. But that first one really kind of laid out our thesis and experience. So the slide, let's see, this is on my left, and I'm assuming it appears the same way, but the analog PDX project is in Portland, Oregon here. You can see that it has a very complex facade. And so, in addition to the building science reasons that we want to limit the penetrations in the facade, we also have situations where, we're trying to achieve an architectural outcome, and having fewer penetrations is beneficial. It's just less to manage on that facade. So that was one consideration here. The other thing that was unique in this particular project is that we had some units where we had kind of a combination of factors where the all-in-one unit was really the only possible outcome. Venting distances would have been difficult, if not impossible, or quite costly with booster fans. And we also have ADA considerations. So to keep the unit accessible, we have to keep the washer and dryer both at a height that is easy to access from a wheelchair. And so you can't stack them, but placing the units side by side takes up quite a bit of floor space. So again, with our kind of more efficient unit floor plans, having that consolidated footprint single unit that's fully accessible was a win for this project. And then the last one that I'll speak to quickly is on the right, project that we have kind of in permitting right now in the Vancouver, Washington area. It's called Ellison Ridge. And this one is more of a walk-up style development. And here we're seeing really the impact of building codes and Washington's energy efficiency drivers kind of helping us to make these decisions. So we have there's a point system that needs to be met with different decisions that you make across the project. And here, to kind of accumulate enough points to meet the code, we were left with a series of kind of trade-off decisions that we could make. And integrating the heat pump dryers was the clearest path to that. So, just as a quick point of comparison, one of the other potential solutions that we had was increasing the U factor of the windows, which would mean going to triple pane windows. And the cost of that was over 3 times just the direct cost of the heat pump dryers. So, we're going to be providing a washer dryer regardless. There's a slight cost premium to go to this without even considering kind of the changes to the venting and the savings there. We were already well ahead by not having to put that money into a window package. So yeah, those have been some of the uses that we've found for these, and I will leave it there for now.
Anders, thank you so much for sharing your experience and your insights with us. Steve and Chris, if you would please go on camera, and if everyone would please open up your audio, we can spend some time answering questions. I've been watching the questions fly, and so let's see, perhaps we can start with one of the questions in relation to ventilation. There are some questions related to the potential for moisture or fragrance that could come as a result of washing laundry. And so your slide navigation is blocking the screen. let me just make a little change with how things here on my screen. Hopefully that will help. And Steve, maybe this is something you could talk a little bit about. So we're talking about airtight buildings and the benefits for making things that way. And could you talk a little bit about the system to make sure the ventilation is appropriate for dealing with the spaces so that there isn't a problem with moisture or unwanted fragrance building up?
Yeah, well, I mean, I think the intent of the question is, so let me back up. So, having a non-venting dryer means we're not sucking air through our enclosure, potentially sucking air through our enclosure, and that can cause problems. So we would like to prevent that. That's not actually fresh air by the time it gets through your wall, because if you ever open up a wall in a 10-year-old building, it's full of dust and insects sometimes, and I don't want to be breathing that. Um, so if it is a vented dryer and you are, if your clothes are quite fragrant, due to whatever you're washing in or anything you're putting in the dry cycle with it, all that is obviously purposely being vented outside. Which is to say, it's pretty hard for you to notice while the cycle is running that those smells are in there. The unvented dryers, I mean, they fairly well seal. That door is got a rubber gasket on it. I have never tested for fragrance, but if you show that graph I had earlier where it's particulates, you can kind of see they're not exactly increasing from dust being and the lint that's building up that's in the drum. It's all being filtered out. It's not being released to the suite. Yeah, you had it. It's not until you open the door, which is going to happen on any dryer. Now, particulates aren't odors, but they should be correlated. And so that's the only answer I have, because I haven't tested for odors.
How about moisture? Is there any issue in relation to moisture if a building, there was concern about ventilation, about it being vented well?
Well, again, the whole point of the unvented is that we don't need that makeup air. And again, we would like to avoid it because that comes with conditioning and it comes with the potential to be sucked from your neighbors. Um, uh, 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 the moisture that's being disposed of in the unvented dryer is usually being poured down the drain. It's not being released into the space. So I'm not expecting any issues there.
Mhm.
And I'll chime in for just a second. I mean, typically with a multifamily property, at least, we do have requirements for air exchange that are already happening. And so, the bathrooms will be
Yeah.
probably continuously vented at some level. So there's already air movement happening through that, and it's moving more to kind of a heat recovery or energy recovery um, system to reduce the energy losses happening with it. But there is constant fresh air that's coming through, and that will be pulling out some. And as long as we're talking about the bathroom, a shower is going to be probably the greatest producer of moisture in a home unit because there's no containment to it. It's kind of small droplets, warm temperature. I mean, you think about kind of what happens to the mirror. There's a lot of moisture that's produced in that. So the laundry is probably a smaller contributor.
Yeah,
Yeah,
thanks
yeah.
for that.
I would say that, yeah, we want our airtight buildings. That means we need mechanical ventilation, and if we could have unvented dryers, that makes everything work better.
Mhm. And then I see another question about air. And does the combination heat pump washer dryer combination push cold air into the room? I know with some, like I think of like a heat pump HVAC, I'm sorry, heat pump water heater that does put some cold air out. Do these washer dryers put some cold air out?
No, we're actually using the cold. We pass the air across both the heating coil and the cooling coil. So it's a sealed system. And the air is kind of constantly passing across. It condenses and then it heats back up when it passes the other coil and goes back into the load. So your net, it's going to generate, like the appliance is going to generate heat that would come into the room if anything. It's not, a massive amount, but it's just like when your refrigerator runs, the compressor gets warm and a refrigerator will put heat into your room as well. So this is similar in that case.
Ah, interesting. Thank you for that. And then I think this might have been mentioned earlier, but could someone remind me what the kilowatt hour difference is between a condensing dryer and comparing, I'm sorry, like a heat pump dryer compared to a condensing dryer or conventional electric dryer?
I don't have that for a condenser dryer. And obviously the kilowatt usage is going to vary depending on how long the unit runs. So in general, it's going to be a 50% reduction in energy usage for the drying portion. So whatever your, go
Go
ahead.
ahead. And
After
I
you.
did measure the difference between the old vented electric resistance dryers and the condensing. They're the same. Turns out it costs the same amount. You're evaporating water, so it's the same amount of energy.
Yeah,
So it's 50% of both of them.
and the other piece of it from a condenser dryer is you also are using, fresh water during the entire dry cycle.
Yeah.
So that's one of the things that people don't understand either. Why is the water running during the dry cycle? But it's actually using the cold tap water to cool and condense the hot, moist air from the drying cycle. So it's condenser dryers use electricity for the heating elements, but then they also use water for cooling that hot, moist air.
And then maybe another question while we have a few minutes. Someone is asking if there is a difference in reliability and maintenance between condensing dryers. We're talking about heat pump dryers and other more traditional dryers. They're thinking about the more conventional dryers as being very straightforward, easy to fix if they break. So do you have any thoughts about your experience with the new combi washer heat pump dryers in
Yeah.
terms of being able to maintain and reliability?
Yeah. So one thing, obviously you're taking two appliances and putting them into one. So it is going to be a more complex appliance when you do that. Um, in general, what we find is keeping your lint filters clean will greatly improve your experience with it. So that's kind of when we talk about reliability, there can be a perception that something, is not working because the filters are dirty. So there is that consumer education piece of it. But in general, we're not, again, we're kind of using existing technologies and putting them together. So there's not some massive difference in terms of how reliable the product is going to be long term. But again, you're taking a washer plus a dryer and putting them together. So it's kind of it's a different experience from that standpoint.
And I mean, I guess
One thing to mention too, sorry to interject one more thing. One thing that we've done with our combo washers dryers is we've actually put a 5-year parts warranty on the dry system as well. So because it is new and consumers may not be as familiar with it, that can give them some peace of mind that that drying system, the parts are covered for 5 years.
and yeah, I mean, where I was going to kind of chime in is, when we're thinking about it from the multifamily building perspective, the reliability of the unit itself is certainly one component of that, but the reliability of the system is also pretty important. And having the vent from the dryer to the exterior is something that requires additional maintenance diligence. It can be, difficult for us to access that when units are occupied. So it becomes a question of, like, is that being cleaned every time that a unit is vacated before someone else moves in? And which is something that's kind of difficult to keep track of. And I think that uh, the implications of it may not be as noticeable. A vented dryer may be able to just kind of brute force its way through continuing to dry, even though the venting is not working as optimally as it should. Whereas you notice a little bit more of that fall off with a heat pump dryer. The potential risk of continuing to dry with a vented dryer where you have a clogged lint filter does create like actual safety concerns. So I think removing that, um, something that we think about as well, just not relying fully on tenants for um, to be doing everything perfectly in order for the building to kind of stand up over time, and not have the risk of a fire or like some other potential issue. Yeah.
Well, we are at time and I want to be respectful of everyone's time. I'm going to put my email address into the chat. It's susan@newbuildings.org. Again, thank you to our panelists. It was really interesting to hear from all of you. And special thanks to Shannon providing technical support and helping to make this event happen. I hope all of you have a good day and look forward to seeing you the next time. And look for an email from us with links to the presentation slides and a recording. Bye, all.